Welcome everyone guys, and today, as I promised and as you voted, we're going to explore and figure out how dictionary works in .NET Core. Basically it's a long topic because you can see how much source code is there, but I can explore the basic ideas under this implementation of dictionary, and we are going to debug the add method, or basically the TryInsert method, because our add method internally calls this TryInsert. We're going to debug it. Yes, I've already copy-pasted this code here and simplified it, because there is no such an easy way to debug system core lib library. You cannot just download and use it or write tests to that code or something. It is so tricky way, so it was easier for me just to copy paste this code in my Visual Studio Code, then simplify it a little bit, because we don't need everything here, at least at add or TryInsert method. Let's try it. Basically, prior to exploring the code, we should have a special background of hash tables. This is algorithmic knowledge. I can reference you to Corman for sure, or you can go by easier way, just go to Wikipedia and try to figure out what hash table is, why do we need the hash table, etc. And one particular special moment, we should understand what is the collision, why it is occurred, and how we can prevent the collisions. And basically in .NET Core, the dictionary uses simple separate chaining method. I'll explain it later by drawing. Yes, it doesn't use linked lists. I don't know why, probably because of memory usage or something like that, I don't know. Because arrays is much cheaper by memory than linked lists. Yes, but anyway, and as you can see, in separate chaining we have buckets and entries. Basically the same we have in our dictionary, or sorry, in .NET Core's dictionary implementation. We have those buckets and entries. Okay, let me explain how those entries and buckets work together, because it is not like trivial things. When I saw the source code, it wasn't like easy to understand thing. Okay, we have our buckets array with some lengths. This is an integer array, so that we have some index and we have integer value by that index. We have a lot of those indexes. Okay, let it be 3 indexes by now. And basically each of those indexes contains the value which is indexed to our entries array. Also we have here an entries array, which also has those indexes. And basically the value here is just an index to entries, and the value in entry array is just our entry, this one, which contains all necessary data. How we can go to buckets? When we go to the add method, first of all we should find our particular bucket in order to follow our entry index and insert or update or throw exception if there is another entry here, whatever. But first of all we need to get to this index. How we can do that? Yes, in .NET every object has getHashCode method, and if you want to use your class as a dictionary key, you should implement getHashCode method at least, which returns uniformly distributed, in the happy path for sure, uniformly distributed hash. And for sure this hash can be any value. It can be a large value, and it may not fit this bucket length. Therefore we apply modulo operator, and we apply modulo with length of this buckets array. And for sure, since we apply modulo, the basic value can be random, like we can first grab this index, then the second value can grab this index, and we have like a hole in this value, because this will have this index, for example, and this will have this index, or sorry, this index, and the hole will be filled with 0 value, which is why actually you can find a lot of comments which is yes, that the value in buckets is 1 based. Why it is like that? Because we can initial, probably, I don't know why .NET Core team did it like that, but probably you just can initialize your array and you already have 0 as an empty field. And if we go and follow particular value and this value is equal to 0, it means that it is empty. You don't need to initialize it specifically for the purpose and mark it like empty value. And each value in buckets, it's the node index itself. It points to the index plus 1. How we can understand this? If we get value in buckets 1, therefore the index 1 minus 1, it is 0 index. If we got index 2, therefore the index in our entries will be first, because 2 minus 1. The formula here is just bucket index minus 1. This is the formula to get index to our entries. Okay, this is simplified version of TryInsert. It is copy-paste and refactored and simplified from this source code. And let me just try to insert and show you how it works internally. Okay, here is my method of TryInsert. It's basically the same as it is in our source code, or sorry, in .NET Core code, but it is a little bit simplified because there is a lot of operations with compiler. In my case, I use only string, and for sure I don't need some special compiler and a lot of compilers. I can get hash code by key itself. I don't need to use compiler for sure. And this if is basically can be reduced by one pass for sure. And this is my refactorings. Okay, this is our code here. This is for first explanations. Okay, I compare both behaviors, the actual dictionary and my dictionary. First of all, we try to insert into my dictionary the value SDF, the key SDF also. My insert behavior is also copy-pasted class here. I can show you. Just copy-pasted versions of actual source code in .NET Core. Let's try it. Okay, I'll compare in the end the dictionary and my dictionary. And okay, the first method, the buckets is null, and we initialize them. We go here and we just allocate memory and initialize everything here. Some assertions. This is the tricky part. Why? Because since the entries is an array itself, probably what this equals operator will do is it just pass the pointer which points to entries to this local variable, but this pointer will point to the same memory in the heap. Probably, I'm not sure how it managed with struct, because the array itself should be in the heap, I suppose. But okay, let it be. We get our hash code, which is this value. Collision count, don't think about that by now. Okay, we get our bucket with ref keyword. It's important in order to you can understand the first explanation. What we actually do here is just get buckets reference, which is 3 count, because it's the minimum prime number. You can explore it deeply in Wikipedia why we should use count is equal to some prime number. It's related to this modular operation and uniformly distributed hash function. We use modulo here with length, and we got some index between 0 and buckets.length minus 1. and we return that index with ref keyword. What actually ref keyword does, it is similar behavior like with pointers in C#, and actually what you can do with that ref, if I have this array and this ref get this local variable by reference, therefore I can access the value in by that index by that local variable. What I mean by that, for example, if I access it like this and I modify this variable to 3, the value under index 2 will not be changed. But in case I use ref keyword, if I do like this, the value under index 2 will be changed. It is important thing to know. Okay, let's move on. We get this get bucket. Yes, right. This bucket points to 0. As I explained earlier, the 0 index means that this bucket is empty. We can put it here. And this while cycle is needed for a collision counter. I'll explain it later also, because you should get the basic things firstly. In our case it goes to break and we just omit it. Therefore free count, I didn't figure out what does it mean and why we should keep it, but we don't use it today. Our counter is equal to 0 since no any element is inserted so far. We check whether count is equal to entries length. If it is, we just resize. If not, we initialize our index variable with value count, and this index is actual index of our entries array. You know what I mean? It is this index in these entries. This is the way how it keeps itself in sequential order and one by one, because every time we add some value, we get this index from our count variable, and the count is sequential by the nature. Okay, we increase count by 1, this count like internal and stateful count. We get our entries also. Now I don't understand this value, why we should do like that, why we don't access the entry itself. Probably it is related to concurrency issue, but maybe not, I'm not sure regarding that, but it is not important. Also we get entry, as you can see, with ref number as well, because we should be able to modify this value without accessing it by index, but by modifying this directly. And this entry is actually empty. It is initialized because it is struct. It is not null because struct is initialized by default. And then we initialize this entry with appropriate values, our hash code, our key, our value, and the next field as well. And the next field as well will point to our current last value in our chain. You'll probably see it when we got collision. We will got it, and then you understand why we do like that. Also, let me explain why we use bucket -1, because as you see, the index -1 means that there is no any next element. If the index of next element is 0, therefore it means that in entries array there is next value to that entry which is located under index 0, if the next is 0. If the next is 1, therefore the next index is 1, and we can access next entry element by accessing entries under first index. And basically you remember this bucket which we grab by ref value here, and here what we actually do, we just set this value in the buckets array. We set the index. You remember that the value in buckets array points to our entries array, and it is 1 based, which means that the index itself is a value -1. Therefore we should put here value +1 in order when we try to get this value, we just get it by index -1 and get the appropriate and correct index. As you remember, the index 0 means actually that this is empty slot, and in order to mark it not empty, we should put here a value bigger than 0. A version is needed for concurrency. It doesn't matter now. Okay, we return true, and let me explore our current state. Okay, we have buckets array with 1 under index 2, which actually means that there is one element in entries array which is located under 1 minus 1, which contains our actual entry. And I can show that I am right by going to entries and go to 0. Yes, this is our value. Okay, let's add another one. Maybe we got here collisions. We do basically the same thing, get buckets. Oh, yes, we got the same bucket. There is a collision. What does it mean? That actual hash code modulo len points to the same index, which is index 2 in our case, which is already reserved. Okay. Now we have entries, we have buckets. We compute this hash code. We get bucket, which equals to 1, and that means that it is not empty, because empty bucket has value 0. Therefore, we should insert somewhere else. And now we get this bucket here, and we follow to its next value. If we remember, under that index we have our entries, and under index 0 we have our entry, which is the value we inserted before, the single value we inserted before. And we go to his next index, we add collision count, yes, and then we go to break method. Okay, it's for collision resolution. Now we do the same things. We grab index as 1 because our count is equal to 1. We increase the count of elements. We get the entry, which is 0. Why? Because it is another index. It is not 0 index, because we increase it sequentially by increasing our count. We get the hash code, and this is the case. Our next field should point to our previous inserted field or entry. And actually, how it can be like that? Currently our bucket points to our previously inserted entry with the first value SDF. And now we inserted another value which collides with our previously inserted value, like SDF. We try to insert SDF2. And in case it collides, we should apply our collision resolution technique, separate chaining, and we just create next index, and this next index should point to previously inserted value, and our previously inserted value is under bucket index. And now you can see that this newly inserted entry has next index to previously inserted entry. We initialize other fields, and here our bucket points to our previously inserted value, which is SDF. Now it should point to our currently inserted value, which is actually our index plus 1, because the buckets is 1 based, and we can access them, and it should be greater than 0. Otherwise, if it is 0, it is empty. In our case, index is 1, but since our rules that it is 1 based, we should also add another 1. Okay, and we increase version. Now I can show you the current state of our dictionary. We have two buckets, or sorry, we have just one bucket which points to this last SDF2 value. How I can ensure that, how I can prove that? Because if we get this value and decrease 1 from that, we will get the entry index 2 minus 1 is equal to 1. Go to the first index in entries, we get this last value. And this last value, this last entry, contains next index which points to the value with the same bucket index. and this index is equal to 0, and if we go to our entries to index 0, we got this SDF entry. Pretty simple, and it contains next value is equal to -1. We can insert another one, SDF3, and explore our state here. In that case, we didn't get collisions, we just have another bucket field with value 3. That means that under entries index 2, which is 3 minus 1, we can get our entry. It is SDF3. We can continue insert our SDF4, but in that case we should resize it. Also we got collisions in that case. 2 collisions. Yes. And now we should resize because our count is equal to length. Okay, after resizing we get our bucket again because the array is resized. We got another index, we increase counter, we got entry, and here we have bucket is equal to 2. That means that the actual value is on the index 1. We set this previously inserted bucket to the next field, and the bucket we set to the current field or current entry. And now we have 3 collided entries by index, I don't know, entries. Let me explore. Here we have SDF4, which points to first index, and first index is the last index. Okay, now I would like to go to resize part in order to bring the better understanding for you guys. Currently, as I showed before, we insert first 3 items as usual operations. We have 3 buckets. Oh, we got 3 collisions. In that case, we have chain in 3 entries, which is connected by next field. I can show you here. We start from the last SDF3. The next is under index 1 in entry array. We go here, the next is under indexed 0 in entry array, and the next is equal to -1, which means that there is no next element. And in case if we are going to insert another element here, and now we should resize our array because the count is equal to length and we cannot add one more entry to our entries length. What this resize function is doing, it gets the next prime number for new size. It is equal to 7. We just copy our entries as they are because they actually are in sequential order, one by one, as you can see, because we sequentially increase counter in order to initialize those entries. And now you should understand that by given n, the value n modulo 3, which was before, is different from value n modulo 7. You can empirically prove it. Therefore, our hashes will be broken because getBucket method will use bucket length, which is changed. Therefore, we should re-index entry hash every single bucket index and bucket value. Resize, yes. Therefore, currently our buckets has length of 7. We go through each of our entries, and this expression will be always true because entry contains either -1 next element or bigger. And then we rehash our bucket by getBuckets. We get modulo here. We return our appropriate bucket for this existed entry, and we just reassign next pointer in case our bucket, which is basically this value, is bigger than 0, then it means that under this bucket there is already another element that we should update also next entry. If it is equal to 0, we just set it to -1, which means that there is no any next element. And then we update the bucket itself. We just put here our entry. We just now update this particular value in this particular index, under this particular index. We update value which corresponds to our new rehashed bucket, because we use another length of our buckets array. And we do that for every single entry, and for sure for every single bucket, because they correspond to each other almost equally. And then we get the updated bucket again. We just perform the same which we performed previously. We update everything here. We set next, which points to 0, therefore this is a complete entry. And then we update our current bucket. That's all, probably. That's all. And now let me show you how the dictionary works. Basically, Visual Studio allows us to debug private fields in dictionary, so that I can show you. As you can see, it also has just null here. After first adding, we have buckets with size 3, and actually our first entry is located under index 0. Here, our entry. Yes, now omit our own dictionary. Try to insert another one. What we got after this. We have two different buckets, and for sure for this index we go to 0 index of entry array. For this index we go to first index of entry array. Trivial case. Now we add another one. Again, no collisions. Also note that getHash function in .NET Core can differ between different deploys and different runs of applications. There is already an issue, and it was done like that because of security purposes, as I know. Okay, let me run across to the last statement. Okay, we have our 5 elements. Also we have resized buckets. Also there is 2 collisions. And let me go to the first element, which is under index 3, or sorry, which is under index 3 minus 1, which is equal to 2. Trivial thing. We go here, entry is equal to 2. There is no collisions here. Okay. We can go to index 4. And under index 4 we have entry which has appropriate next index, which points to first index of entry array. We can go here. Our first index is the last. Basically we can go to fifths now. Or sorry, fourth. Yes, and also we can go to third index and see that there is next element also under index 0. Something like that. As you can see, the behavior is exactly the same. This is how the dictionary internally works. I think it's pretty enough to explore our basics, something about hash tables and algorithms regarding that, collision resolving, dictionary implementation of add method, or basically the TryInsert method and Resize method. If you are interested in that, I also can explore another functions, for example, how the find value works. Find value is actually a function, or sorry, method which is used for contains k, try get value, etc. It basically try to find the value under this k. I also can explore this function in more details if you are interested in. Since I'm on my own channel, you can see other my videos, for example how to implement Instagram bots or mock interview for .NET middle position, etc. Also don't forget to subscribe to my Instagram account. Here is my Instagram account, programming space underscore dot underscore space and programming. I publish here some additional information, for example book screens. I have voting system here in order you can choose what you want to see, etc. So please subscribe, and thank you for your attention, and goodbye.